So, good morning all of you. We have come a long way starting with the photoelectric effect, which substantiated the idea of Planck that electromagnetic radiation can be looked upon not only as a wave phenomenon but also as a quote unquote particle phenomena consisting of quantized packets of energy called photons. As I have told you, Planck himself did not particularly believe in the reality of photons. He thought it was only a kind of intermediate step or an effective language to describe what was happening during the interaction of radiation with matter. However, Einstein took this concept very seriously and he was able to explain all the great experiments of Hertz and Lenard and Millikan most importantly. Further experiments by Compton completely established that the photon picture is a perfectly valid picture even if it is in sort of disagreement or contradiction with the wave picture. And the next step came when Rutherford performed his experiments in order to determine the structure of the atom, and he gave the planetary model, the so called Rutherford model. We have discussed that at the great length. However, the planetary model gave rise to its own problems because the distribution of the electrons around the atom, if you imagine that there are orbits like that of planets, they were in highly discrete orbits, and in particular an atom in the ground state should not have been stable at all according to classical electromagnetic theory, because every accelerating charged particle should radiate. So, when it radiates it loses energy, and when it loses energy it starts falling into the nucleus. In particular, the most abundant atom that we have, hydrogen atom, should not be stable. In fact, it should not have lived or existed for more than 10 to the power of minus 9 or minus 8 seconds after it was formed. But we know that the universe is billions of years old, so that was a major problem. So, again we see that there is a tussle or a tension between the classical concepts and what experiments are revealing to us, very much like what happened in the case of the photon. And now the next thing that we studied was that it was the turn of Bohr, who again brought in the picture of photon and also the concept of quantization, not only in the energy of the electromagnetic radiation but also in the allowed orbits. So, once the Bohr model came, then a whole lot of things were understood, and in particular the discrete spectral lines were understood. The famous Lyman, Balmer, Paschen, Hund, all these series were understood. The mysterious constant, the Rydberg constant, was simply a combination of the fundamental constants or fundamental parameters, mass of the electron, charge of the electron, Planck constant and the speed of light. So, everything seems to fall in place. So, the next question that we have to ask, apart from other important questions, is what would the nucleus be made of? This is a very, very important question for us, because all that Rutherford scattering experiment revealed, it was elastic scattering, was that atom consists of mostly empty space. Electrons can be treated as sort of point particles, they are much, much smaller than the nucleus, and all the mass of the atom is constrained or contained in a very small volume inside the atom. So, let us start with that. So, to write a picture of the atom, so we have a nucleus, positive charge which is concentrated there, and then you have the electron orbits. We are drawing it in a plane, of course they are all in space, and Bohr quantization does not tell you in which plane my circular orbit is, it really is immaterial. Now, to give you a scale, what we are saying is that this length is of the order of 10 to the power of minus 8 centimeters or 0.1 nanometer, 0.01 nanometers let us say, whereas if I were to magnify this, so I am magnifying this blot, this is of the order of 10 to the power of minus 15 meters. and this is of the order of 10 to the power of minus 10 meters. So we are speaking of a factor of 10 to the power of 5 or 100,000 between the size of the atom and the size of the nucleus. We know that the nucleus contains positive charge for sure because atoms are electrically neutral. Therefore, the big question is, what is it that the nucleus is made of? And if it consists entirely of positive charge, what is it that holds together? So we have a number of questions to ask.